Hello guys, so today we're going to be talking about adding and subtracting one-step equations. So before we get started, we're going to talk about some strategies for solving equations. First, you must isolate the variable by undoing the operation that is there through inverse operations to both sides of the equations, and you always want to make sure that it's balanced. So before we actually start, let's talk about what inverse operations are. So if you're talking about the inverse operation of addition, that would be the opposite operation of addition, which is subtraction. The inverse operation of subtraction, or the opposite of subtraction, would be addition. The inverse operation of division is multiplication. And the inverse operation of multiplication is division. Okay, and we're going to be using the inverse operation, like we said, to undo what has been done to our variable and then therefore isolate the variable. All right, guys, so to start us off pretty easy, we're going to look at number 1. It says x minus 3 equals negative 12. So what we're trying to do here is solve for x, and how we're going to start is we are going to draw a line down our equal sign to split up the equation so that we can keep both sides balanced and kind of keeps us organized. Okay, so as you can see, the x is being subtracted by 3, so we're going to use the inverse operation to get rid of the 3. So we are going to add 3 to this side, and what we do to one side, we have to do to the other side. Okay? Now again, the reason we're using the inverse operation is because if we have a negative 3 with the x right now, and we add a positive 3 to that side, we're going to get rid of the 3's on the side that are variable, and that will just leave us with x on this side. Okay, those 3's go away because a negative 3 and a positive 3 would make 0. But like I said, what we do to one side, we have to do to the other side. So we've got a negative 12, and we're adding 3 to that. So a negative 12 and a positive 3 would give us a negative 9, and we're done. X equals negative 9. Now if you go back to the original problem and you were to plug in a negative 9 to where that x is, so negative 9 minus 3, okay, if you do keep, change, we do get negative 12 as our solution, therefore we did it correctly. Okay, so x equals negative 9 is the answer for the first one. When you look at number 2, we're still going to do the same thing. We're going to draw a line down our equal sign to keep our equation balanced and to keep us organized. If you can see over here, we are adding a negative 5 to y. Okay, so we're going to do the inverse operation. Now remember that adding a negative is the same thing as subtracting. So we are going to add 5 to this side. Means we have to also add 5 to the other side to keep it balanced. Again, if you look here, a negative 5 and a positive 5, that would equal out to 0 on the side with our variable, which means we have y alone. We have isolated the y. Okay? So like I said, what we do to one side, we have to do the other. So 10 plus 5 would give me 15. So y equals 15. Now remember, you can go back and check yourself. Plug in 15 for this y right here. So negative 5 plus 15. Is negative 5 plus 15 10? Yes, it is, and that's what we got over here on this side, so we did it correctly. Okay guys, so I'm going to do one more with you before I want you to try some on your own. For number 3, we're still going to do the same thing, draw a line down our equal sign to keep our equation balanced. If you see, we've got y minus 3 4/10, so we are going to use the inverse operation, which is addition. So we're going to add 3 4/10 to both sides. which isolates our variable. So we have y on one side because we've got a negative 3 4/10 and a positive 3 4/10, which zero out. And then on the right-hand side, we just need to do 7 plus 3 4/10, which would be 10 4/10. So y equals 10 4/10. Again, you can go back and check yourself by plugging y into the original problem and see if 10 4/10 minus 3 4/10 gives you 7, and it does. So I want you guys to try number 4, 5, and 6 on your own, and then come back to the video to check your work. Okay, for this next one, it is written backwards, but you still use the same process. You could rewrite it if you would like to and put w minus 12 equals negative 23 5/10, but I'm just going to keep it as is. Since we have a, you're subtracting 12, you're going to add 12 to both sides. Okay, which would give you w on this side equals negative 11 5/10. For number 5, okay, I would do keep change here first, because that helps you see that you need to subtract 10 to both sides. Okay, bring down your p, and negative 12 1/10 minus 10 would give you negative 22 1/10. And then for the last one, again, it's written backwards. You can do the same process. You would add 5 2/10 to both sides, which would give you 11 2/10 equals p. All right, flip it over and we're going to do the next questions. So even with fractions, you're going to be using the exact same process. Okay, so since we have 5/12, positive 5/12 on one side, you're adding 5/12 on one side, we're going to subtract 5/12 on this side, subtract 5/12 on this side, keeping it balanced. We'll bring down our y, and then we need to subtract 1 minus 5/12. So you're going to need to make common denominators here. So put your 1 over 1. Common denominator would be 12. So you're going to multiply this first number by 12, the top and the bottom. And that gives you 12 over 12 minus 5 over 12. Subtract our numerators. 12 minus 5 would give us 7/12. So y equals 7/12. Okay, for number 8, we're going to do the same thing. We have a minus 3/5 equals 7/10. Since a is being subtracted by 3/5, we are going to add 3/5 to both sides. Okay, this leaves us with a on this side, and then we need to do 7/10 plus 3/5. So again, we need to make common denominators, which our common denominator would be 10. So we need to multiply 7/10 by 1, which just stays 7/10. And then we need to multiply 3/5 by 2 to get 6/10. And that means that a will equal 13/10, which is an improper fraction, so we need to change it to a mixed number. 10 goes into 13 one time with 3 left over. So a equals 1 3/10. All right, I want you to try 9, 10, and 11, and then come back to check your work on the video. Okay, for number 9, you would subtract 5/8 on both sides. Leaves you with j on your left side. Your common denominator is 16. So you're going to multiply that first fraction by 1, which just keeps it as 1 and 11 over 16. And then you're going to multiply the second fraction by 2, which gives you 10 over 16. 11 minus 10 is 1, so you're left with 1 and 1/16. For number 10, you would subtract 2 and 3/4 from both sides. That leaves you with m equals on your left side, and then you need to probably rewrite the problem. -2 and 3/4, and make common denominators. You'd multiply 1/2 by 2 to get -2/4. Keep change means that you're going to add the two fractions together. So 3 and 2 would give me 5 as my numerator, and keep my 4. That is an improper fraction, so we need to change this. See how many times 4 can go into 5. It goes in 1 additional time, so your whole numbers become a 3 with 1 left over. So m equals 3 and 1/4. And it is going to be negative, because the original problem had 2 negatives. Lastly, you would add 8/9 to both sides, which leaves us with h equals, you'd make common denominators, which would be 18, so we have -17/18 plus 16/18. -17 plus 16 would leave you with a -1/18. That's what h equals. Again, you could go back and plug these fractions into the original problem to double check that they are correct. All right, that's it. Go ahead and grab your practice, and you may put this in the notes section of your binder. And please make sure to upload a picture on Google Classroom.